Okay, this is going to be a review for the sixth grade True North final science exam for the whole year. And some of these questions are pretty easy and straightforward. Some of them are quite difficult and complicated. Some of them I'm going to use the board, but most of them I'm just going to read the questions and answer them. And disclaimer, these are not official answers, so there's always a possibility that I might say something that's not exactly what the teacher is looking for, but this is the best compilation of my knowledge and the research that I did for what I didn't know exactly. So, to begin, what is a galaxy? So, a galaxy has to be a massive system in space that is composed predominantly of stars, but also can include dust, smaller celestial objects, gases, and also something called dark matter. And the question that goes with it, what holds a galaxy together? A galaxy, all the objects with mass inside a galaxy are held together by gravity. What is a light year? So this, some people get confused about. They hear year and they think that it is a measure of time. A light year is a measure of distance. It is the distance that light will travel within a year. And considering that light travels incredibly fast, obviously it's the fastest thing in the universe and nothing can move faster than it. The distance it travels in a year is so far that it's basically inconceivable to human brains. We can't even picture it. But it's you measure the distances between stars and galaxies in light years. What is the electromagnetic spectrum? So the spectrum, that's the entire range of frequencies of electromagnetic radiation, with the lowest frequency being radio waves, the highest frequency being microwaves, and then light waves, visible light, being somewhere in the middle of that spectrum. So what's changing across the range, that is the difference between one kind of electromagnetic radiation and another, is the frequency. How do you determine the wavelength of a light wave? So this is a wave, any wave, but we'll call this an electromagnetic wave. And it's important to remember that the wavelength is the distance between any consecutive peaks of the wave. So between here and here will be exactly the same as between here and here, will be exactly the same as between here and here. They're all exactly the same distance between any two peaks, consecutive peaks of any electromagnetic wave. And so the wavelength is that distance, and then the other important factor about an electromagnetic wave is its frequency, which is, you can look at it as how close the peaks are to each other, or how many peaks you can expect to see within a unit of time. So if I wanted to double the frequency, I don't think I exactly doubled it, but you get the idea. Then the wavelength becomes smaller. So as you increase the frequency, you decrease the wavelength by a proportional amount. And the way that it's expressed is the wavelength. This is a lambda, by the way. It's the scientific symbol for wavelength. This is c, which is the speed of light, divided by the frequency. I'm not sure they taught this at a very high level of physics. I doubt they did. So probably best to just try and understand this. I think I need it darker. See if this one's darker. Yeah, that's better. C is a constant. It never changes. It's the physical constant of the speed of light. So the wavelength lambda equals c divided by the frequency. And the wavelength and the frequency are inversely proportional. what are the layers of the sun? So going from inside to outside, it's the core, the radiative zone, convective zone, photosphere, chromosphere, corona. So that can be hard to remember, those 6 layers. So I would say always think about the inside, the core. Okay, we can remember that the innermost layer of something, like an apple, a baseball, is the core. Okay. Similarly, we can think about the outside, the corona. The corona is a crown. It's just like when you put a crown on a king's head, that's a coronation. Corona is Latin for crown. So that is always on the outside. A coronavirus is named for the sort of crown appearance of the outside of the virus. So once we remember that the core is the very inside, the corona, the crown, is the very outside, then we just have to remember the other 4 layers. You can try RCPC. Try that. So radiative, convective, photosphere, chromosphere. So you start with core, then R, C, P, C, and then corona. There's probably some better mnemonic for that, but that's what I came up with in the short term. Core, radiative, convective, photosphere, chromosphere, corona on the outside. Where does nuclear fusion take place in the sun? It takes place in the core. So just remember, the fusion, the high energy, the hottest, that's right there in this very center of the sun, the deepest part of the sun. Draw the moon's phases, beginning with a new moon. Okay. This one can be hard to remember as well. There's a couple of tricks. So, new moon, you don't see anything. When it's new, it's empty. And that's because basically the entire moon is dark. There's no sunlight. It's still there, but there's no sunlight reflecting off it, so you don't see it at all. So you go from that, we'll just diagram it as like this dotted line, which you don't see, but that's just how you know where it is. And then we go to something called a waxing crescent. Now, how do we remember waxing and waning? Well, waxing means it's getting bigger. Waning means it's getting smaller. So obviously, if you start from nothing, you've got to be getting bigger. You got nowhere to go but up. So this is a waxing crescent. The other thing you have to remember is that the change comes from the right side. So this is where you first see the light. So this is new waxing crescent. And then it's important to remember this is going to be the, maybe we'll just put this to show the lighted side. This is called first quarter. This is a little confusing as well because it looks like half the circle is filled. And some people will call this a half moon. But this is called, the official name for this is first quarter that we see over here. Now, we're going to go further. And now we've got most of the moon that you can see. And again, remember, it's still waxing, still getting bigger. And the word for this shape is gibbous. Gibbous. So let's just go straight down over here. Next thing, we should know what that's going to be. That's going to be the full moon. Now remember, the change is still coming from the right, but the moon is going to start shrinking. So this is going to be the dark part over here. This is going to be the lighted part in here, and that is going to be waning gibbous. Remember, waning is getting smaller. Then we're going to have third quarter. This is going to be the lighted half on the left side. So you can see the difference between the first quarter and the third quarter. And then this is going to be the lighted part. This is the part you don't see, just the outline. And this is going to be waning crescent. Remember, it's still getting smaller. And then we go back to the new moon. So those are basically 1, 2, 3, 4. Those are the 8 phases of the moon. All right, we haven't gotten very far. What causes day and night? So what causes there to be day and night is the rotation of the Earth on its own axis. The part of the Earth that's facing the sun is day. The part of Earth that's facing away from the sun is night. So that's the rotation of the Earth on its own axis. Now, if they ask you what causes the seasons, remember that the seasons change over a year, not a day. And that is your hint that seasons are related to the revolution of the Earth around the sun. And it's not how far the Earth is from the sun. Even though the Earth has a slightly elliptical orbit, it doesn't make enough, there's not enough variation in the distance along the ellipse for that to really affect the warmth of the Earth. What it is the tilt of the Earth on its axis as it revolves around the sun that leads to the seasons. And basically, because of the tilt of the Earth, the areas around the equator get more sunlight, direct sunlight throughout the year, and as you go further towards the poles, it changes how much light and warmth they get during various parts of the year. So areas that are closer to the poles will get more light and warmth in some parts of the year, and they will get less light, which when they get more, it's the summer. When they get less light and warmth, it is the winter. But they never will get as much near the poles as they get in the center of the Earth, where the shining of the sun is much more direct. So that's all the detail I'm going to go into about the seasons and the Earth's tilt. What is a geocentric model of the solar system? Very important to understand for a lot of these questions. Geo is, I believe, is it Greek? It's the prefix that means Earth. So geocentric means the old model that they, maybe the Greeks had and was still popular right up until the time of Galileo, that the Earth had to be the center of the solar system, of the universe, in fact, and everything else, the sun, the stars, they rotate around the Earth. Helio is Greek for sun. So heliocentric model is the correct model, which is that the Earth and the other planets and everything in the solar system revolve around the sun. Why does the Earth rotate around the sun? And really they should, I think, say revolve to keep things in consistent. So the Earth revolves around the sun. We'll do this orbit again. Because there are always two forces acting on the Earth, or any other, one object that rotates around the other. There's a gravitational force, which is pulling it towards the sun, and there is inertia, which is tangential to the circle. That's basically the force that the Earth has always been moving, and there's nothing out there to slow it down. The orbit, the circular orbit of the Earth, is basically the sum of these two force vectors. And anywhere that you place the Earth in the orbit, you always have these same two force vectors, and the curved path is basically the sum of the two vectors. If, for whatever reason, something ever started to slow down the Earth's orbit would get closer to the sun. If you slowed down the Earth enough, it would fall into the sun. But that's not about to happen. If something ever stopped gravity, which is also not about to happen, the Earth would just fly off into space because of its inertia along a straight line. Whatever moment you turned off gravity, the Earth would just continue on that trajectory, whatever was tangential to its spot on the circle when gravity got turned off. What factors affect the force of gravity between two objects? It's basically the masses of each object and the distance between them. Now, the only object in our in our experience that has enough mass to have a detectable force of gravity is the Earth. You can't feel the gravity of any other object because the Earth is millions of times more massive than any other object that would be in your experience. So there's still a gravitational force between this Sharpie and this paper, but it's so tiny I would need specialized instruments to detect them. The larger I made this object, the more gravity would be. The larger I made this object, the more gravity. The closer I bring them together, the more gravity. The further apart I bring the two objects, the less gravity. The two factors that keep the planets in orbit, we already discussed that. Gravity and inertia. Where is the asteroid belt located? Well, let's just quickly review the positions of the planets. Sun, and we've got Mercury, Venus, Earth, Mars, asteroids, Jupiter, Saturn, Neptune, Uranus. And, if you're as old as I am, you can remember when Pluto was a planet, but they took it away. They took away its planet privileges, and now it's a dwarf planet. So on this side, closer to the sun from the asteroid belt, are the terrestrial planets, which basically mean they're made entirely of solid material. And to this side are the gas giants, which most of the evidence indicates that they have a solid core, but by far the majority of their volume, I'm not sure about their mass, but the majority of their volume is made up of gas. By the way, even though Mercury is closer to the sun than Venus, Venus is the hottest planet because of greenhouse effect in its atmosphere, which we will get to later. So what's the same about the inner planets? They are terrestrial, they're made mostly of rock. Outer planets, mostly gaseous. Why do temperatures on the moon vary more than Earth? The reason for that is that the moon has no atmosphere. So the atmosphere on the Earth acts as an insulator and a regulator. It kind of smooths the variation between day and night. So during the day, the Earth warms, and because of the atmosphere, we hold on to that warmth during the night. We don't drop down to far sub-zero temperatures at night the way the moon does. And because the atmosphere limits the amount of heat that hits the Earth, and the amount of like ultraviolet light and radiation that hit the Earth, we don't fry every day. So it's basically the atmosphere that blunts the variation of temperatures on the Earth. Fertile soil is important because I assume you need fertile soil to grow plants, and you need plants to keep animals and humans alive. So that's important to us. Fertilizers and pesticides are examples of water pollution because even though they're used on land, groundwater and runoff cause that material to leach out of the soil, and eventually they end up in bodies of water like lakes, rivers, and oceans. How does the ozone layer benefit the Earth? So the ozone layer protects the Earth from UV radiation, which is important for life on Earth, and it also helps to stabilize the climate. So it's one of those layers of the atmosphere that prevents the Earth from getting too hot and too cold. So it doesn't exactly benefit the Earth, but it benefits life on Earth. What is abrasion in regards to weathering? So abrasion is just like sanding. So wind can weather to a certain degree, but the process is dramatically accelerated. When wind picks up sand, the sand acts as an abrasive. It will rapidly wear down rock, especially soft rock like limestone, things like that. What is a slump in regards to a mass movement of land? So a slump basically is kind of like a landslide. It's like a sort of a particular shape, which they describe as like a spoon-shaped path. I'm not sure if that's going to be important for the test or not, but that's what my research said that slump is. But probably the best way to think of it is in terms of like a landslide, large quantity of land moving downhill. What kind of weathering causes an actual change in minerals or rocks? So when you talk about a change in a mineral or a change in a rock, that is a hint they are talking about chemical change. When you are just breaking a piece of rock, or you are otherwise sort of breaking down, grinding, abrasion on a piece of rock, that is not an actual change in the minerals. But chemicals like water or acids like carbonic acid and acid rain can actually cause chemical changes in rock. For example, oxidization, which is basically rusting of iron in rock, or dissolving of limestone by carbonic acid. What landforms are often created by wind? We're going to say for this dunes and desert pavement. I believe those are the ones that they learned about in school. There are others. What landforms are at the lowest elevation in Florida? Going to say coastal plains, beaches, and wetlands like the Everglades. What type of air masses create humidity in tropical weather? We're going to go with maritime tropical air masses. Maritime means over the ocean. Tropical basically refers to tropical latitudes that are closer to the equator. That's where you have the most humidity and warmth. What weather instrument measures air temperature? A thermometer. If they ask for air pressure, that is a barometer. So just make sure that question is being read carefully so you know which instrument to write down. They're not that hard to remember. What is a star of the water cycle? I assume they mean the sun, and that's kind of like a sort of a cute question. that the sun is very important, obviously, in causing evaporation, which brings water back into the atmosphere. What is a rain shadow? So this is something I had to learn. I'd never heard of this really before. And the first thing I thought of was that something's acting as kind of like an umbrella from physically blocking water from the rain from hitting something, and that's actually not what it is. So a rain shadow occurs when you have mountains that are close to the coastline. Then you have air coming over the water, and this air gets wet because it picks up humidity, it picks up water from the ocean. It rises, and as it rises, the air cools, and when the wet air cools, it releases the water. So it rains all over this part of the mountain. By the time the air gets to the top of the mountain, it's dry. There's no air left. And then when it goes over here, there's no rain. So this is the rain shadow. It's the area behind or inland from the coastal mountains. One thing they will call this area, they will call this the windward side, and they will call this the leeward side. So it's the inland side or the leeward side of a coastal mountain range. That's where you get a rain shadow. Where does most precipitation fall? It falls in the tropical regions, and also it falls on the windward side of coastal mountains. What does a graduated cylinder measure? It measures volume, right? The graduations on the cylinder tells you how much of a liquid that you have put in it. That one should be fairly easy. Now, here's where things get very tough for a lot of kids. What is a hypothesis? I'm going to jump and I'm going to answer the law and the theory. What is the difference between a scientific hypothesis, a law, and a theory? So a hypothesis is kind of like an educated guess that you use to start an experiment. You're sort of guessing what the result will be, and then you objectively run the experiment without any kind of favoritism towards your hypothesis, and you say the hypothesis at the end was correct, or the hypothesis is disproven, or I was unable to gather enough information to make a judgment about whether the hypothesis is correct or false. Now, what is a theory? Now, the problem with the word theory is that the meaning has changed in like recent decades, and people have started using the word theory as though it's a synonym of hypothesis, which is not. So if you're in a detective movie and you gather all the suspects together and you say, well, I'm going to tell you about my theory of who committed the murder, you're actually using the word theory incorrectly. You should be saying, I'm going to tell you my hypothesis. But that just doesn't sound right anymore. So people say theory, and people use this to confuse people. For example, evolutionary theory. They say it's a theory. It's not proven. It's not, it's just one possible theory. But that's not really what evolutionary theory means. So what the word theory actually means is it's a widely accepted explanation of some natural phenomenon which is based on a large amount of evidence and can be used to make predictions. So when you describe something as a theory, evolutionary theory, gravitational theory, theory of relativity, they're basically proven. They are true. The scientific community is satisfied. Now, that doesn't mean that every single aspect within the entire theory is like irrevocably solid. Little parts of the theory on the periphery, which might not only have the status of hypotheses, might be modified, they might be changed, but the general principles of the theory are basically rock solid. Now, it might be impossible to completely prove a theory to the degree that 1 + 1 = 2. but there's so much evidence and it's been so predictive of all natural phenomena, it's just accepted as fact. What is a scientific law? Now that is something that you can prove. It's basically a scientific law is like a solid fact of the physical world that's always true. You can demonstrate it. For example, a scientific law would be that when you drop an object for a height, it always accelerates. The acceleration of the object towards the earth is always the constant g, or that the speed of light is c. These are examples of scientific laws. When you do an experiment, what are the difference between an independent variable and a dependent variable? Well, let's take the example of a experiment where you're trying to decide whether plants grow taller when they have more light or when they have less light, or if it makes any difference. So you have a bunch of plants that you keep indoors, you have a bunch of plants that you keep far away from any window light, you have a bunch of plants you keep in the sunlight. So the independent variable just means something that changes. The independent variable is the variable that you're controlling in the experiment, the thing that you're intentionally changing. So in this case, it's the amount of sunlight. The dependent variable is something you don't control, it's something you're measuring. So in this case, it would be the height that the plant grows in some amount of time. If you're going to do a controlled experiment, it's very important not to have any other variables, to only have one independent variable. So if you're using different kind of plants in your experiment, it's not going to work because now you've introduced a new variable, the species of plant, and it's going to confound the experiment because now you don't know whether the plant's growing taller because you're using a different species of plant or because there's more light. So in the example, independent variable, amount of light, and a dependent variable, how tall the plant grows. Controlled experiment, because nothing is different about what is happening with the plants except the amount of light that they are getting. What does it mean to communicate your findings in an experiment? Tell other people, either verbally, write it down, whatever. That's kind of an obvious one. What is evidence? Evidence is data. So observations, measurements, for example, that support or argue against scientific hypothesis. What is an opinion? An opinion is a belief. It either has not been proven or it cannot be proven because it's subjective. What is a greenhouse? So a greenhouse is any enclosed area which is made or has a roof of a transparent material that allows the entrance of sunlight, allows the entrance of light and heat from the sun, and then traps warmth and also traps humidity inside to optimize typically the growth of plants. When we talk about the greenhouse effect, it means we're turning the entire planet into a greenhouse by creating this invisible layer, generally of greenhouse gases in the atmosphere, specifically carbon dioxide, that's similar to like panes of glass or transparent vinyl or plastic, permit the entrance of light and heat through it, and also trap those things so that they don't normally escape the atmosphere through convection as quickly as they normally do. What is a botanist? It's a scientist who studies plants. Scientific laws, scientific theory, we just went over those things. Doppler radar is a confusing concept to understand. Radar itself means bouncing radio waves, which are long, low frequency, high wavelength waves off an object, and then when they bounce back to the antenna, basically from the time it takes for them to hit the object and bounce back, we can place where the object is relative to the antenna. That's what radar is, the radar that they use for like determining where airplanes are, objects in the sky. Now, specifically, Doppler radar relates to objects that are moving. And this takes, the Doppler radar uses the physical phenomenon that when a wave hits an object that is moving, it will change the frequency of the wave. And an object that is moving towards you will create a higher frequency wave, and an object that's moving away from you will cause a lower frequency wave. And you can measure not only the distance of the object by how long it takes, the wave takes to come back, but also the direction that it's moving by the change in the frequency of the wave. And it's specifically something that's used for precipitation. They're showing whether the mass of rain or snow or hail or whatever it is moving towards the antenna or away from the antenna. What is El Nino? So El Nino, I used to think, I always thought that it was an ocean current, but apparently that's not correct. El Nino is an entire collection of weather phenomena that occur every few years, unpredictably. Could be within 2 years or it could be 7 years, but it's somewhat unpredictable. And it's based on the warmth of the surface of the Pacific Ocean. That can cause a reversal of the normal pattern of trade winds, which then in turn affects ocean currents. The ultimate effect of El Nino is it can exaggerate the amount or lack of precipitation in certain areas. So some areas where it rains become flood and they become much more rainy. Other areas which tend to be dry will experience droughts during El Nino. What is a geologist? Ologist, obviously science, geo, earth. So it's a scientist who studies things that are related specifically to the earth, to non-living things and phenomena on the earth. Seismic waves are waves created by an earthquake. How did geologists decide the earth had layers on the inside? This is something else I did not know until I read this question. So when the earth shakes, when there's an earthquake, it generates two kinds of waves. One of those kinds of waves cannot travel through liquid. It basically is dampened by liquid. And what they found is that if there's an earthquake in this particular spot on the earth, that you might be able to detect those waves that don't travel through liquid over here, but you can't see them over here. So there's a shadow over here because this liquid area, which is outside the core, dampens those waves that can't pass through liquid. So by mapping these shadows, they were able to determine that there's a layer around the core that is liquid, and they were able to determine how thick it is. What is an element's half-life measuring? So that specifically refers to a radioactive element. A radioactive element is unstable, I think for reasons that we don't really need to go into, but radioactive elements emit particles, which is radioactivity, because they're trying to find a more stable state. And the half-life of an element is the amount of time it takes for half of that mass to decay and become stable, and become a stable isotope. After another half-life goes by, half of what remains is gone. And after a third half-life, half of what remains gone. So after 3 half-lives, you only have 1/8 of what you started with. And then it just continues ad infinitum. Of course, eventually you get down to the sort of atomic level. You can't get any smaller than that. So it doesn't occur infinitely. Eventually, every atom has decayed. And what is radioactive dating? So radioactive dating, the most common form is using an isotope called carbon-14, which again is unstable on the broad scheme of things, but it's not, as far as radioactive isotopes go, it's relatively stable. So it takes like 750 years to decay, or that's the half-life for half of it to decay. Now, carbon-14 is a naturally occurring isotope, and since we're constantly turning over the carbon in our bodies, when we eat, we're bringing in new carbon. When we breathe, we're breathing out old carbon. And, one carbon atom that's like somewhere within your arm is not going to stay in your body. Eventually, it's just going to cycle through. It's going to be emitted from your body. So the amount of carbon-14 while you're alive, or while any living organism is alive, stays constant relative to the other stable non-radioactive carbon isotope. So you have that normal proportion until the organism dies. At that point, the organism stops turning over carbon. No new carbon-14 goes into the body. So carbon-14 dating works on living organisms at the moment that they die. That's when you start counting. So you can measure the amount of carbon-14, or the proportion of carbon-14 to regular carbon in any remnant, like a skeleton of a living organism, and basically from the proportion, like let's say there's half the expected amount of carbon-14. That means it's 750 years since that organism died. Let's say there's a quarter of the expected amount of carbon-14. That means it's 1,500 years since the organism died. What part of our body will be a fossil? The bones. It's actually, when you dig up a fossil, it's not the bones that stuck around, interestingly enough. There's no organic living material left in there. It's all minerals that basically soaked into the bones and took their shape, and that's really what we're digging up. Wegener published the theory of continental drift. What is some evidence that points to its truth? So continental drift is it a hypothesis or a theory? I'm not really sure to what degree it's universally accepted, but I believe it's pretty good. Is that at one point there was just one continent called Pangaea, and everywhere around it was ocean, and then over time the continental plates separated, and we got the sort of the profile, that we are familiar with, like Europe and Africa, etc. And so what is the evidence? Well, the evidence is that you can find areas of coastline. Obviously, the coastline has changed over millions of years since the continents separated, so they don't fit together exactly like a puzzle, but there are a lot of similarities in the outlines when they're separated by oceans. The second thing is that you find fossils of animals that existed before the continents separated, and they're very similar. So over here you might find the fossil, and you might find very similar fossils over here. Over here you might find a fossil, and you might find very similar ones over here. Why would you have just those animals? It's not like there's any way they could cross from one side to another. So it indicates at one point it was one population of animals, and then the plates pulled apart, and half the bones ended up on this side and half the bones ended up on this side. Draw a diagram of the continental shelf. So the important thing to remember about the continental shelf is that initially there's just a small dip, and that's the shelf over here. This is land. This is the ocean. And then it drops off much more and you get into the real ocean floor. So these things, of course, they all have names and everything, but I'm not really going to get into it. Draw a diagram of the mid-ocean ridge. I don't think I really prepared for that, but obviously where the plates push together, they push up a ridge just like an underwater mountain ridge, just like mountain ranges on land where plates meet together. So one plate, another plate, and the ridge between them. Where does seafloor spreading happen? At the mid-ocean ridge. So sometimes plates push together and sometimes they pull apart. Where the plates pull apart, magma, molten rock comes up from the surface, and it comes up here, and this is the ocean floor. The magma solidifies, it expands, and it pushes the seafloor apart, spreading. What provides heat inside the Earth? The Earth's molten, the core and the molten layer around it. What is the difference between radiation, convection, and conduction? Radiation is typically a source of heat or energy that is transmitted through that can be transmitted through the vacuum. So radiation comes from the sun. It doesn't require any kind of medium, any kind of air or liquid. It just flies directly through space. So, light energy, infrared, ultraviolet, all that kind of energy travels through space, and that is radiation. Convection requires a gaseous or liquid medium. So it's heat transferred through a gas or a liquid, and conduction is heat transfer between two objects that are touching. So if you're boiling pasta from the cooktop surface to the pot, that is conduction of heat. From the pot through the water to the pasta, that is convection of heat. So when you cook pasta on a cooktop, you're using both conduction and convection. Where do convection currents occur? Some examples I found in the atmosphere, in the ocean, and the Earth's mantle. Where do the biosphere and the atmosphere interact? Well, let's just say, what are the geosphere, atmosphere, biosphere, and cryosphere? Geo, Earth. So geosphere is basically like all like the inorganic parts of the Earth and the Earth's surface. Atmosphere is all the gases that are outside of the Earth's surface. Biosphere is all the living organisms on the Earth's surface and in the oceans. Cryosphere is all the ice on the Earth's surface. Where do biosphere and atmosphere interact? Well, anywhere, basically everywhere where there are living organisms, they interact with the atmosphere, because all living organisms absorb gases from the atmosphere and emit gases into the atmosphere. Plants absorb carbon dioxide, emit oxygen. Animals in general do the opposite. What has climate change mostly been attributed to in recent years? Man-made carbon dioxide or carbon dioxide released into the atmosphere as a result of human activity is a greenhouse gas, as we discussed, traps, allows heat and light to pass through, and traps it so it doesn't diffuse outward into space via convection at the same rate that it normally does. So I believe I went through every question. Again, I cannot guarantee that these answers will all be marked correct on a test, but that is, I think, the best I could come up with. So everybody, good luck tomorrow.